Real-life triangle problems. OP is measuring the height of a building. He stands 50 meters away from the building on level ground and measures the angle of elevation to the top of the building as 75 degrees. His eye level is 1.7 meters above the ground. What is the height of the building to one decimal place? So let's suppose OP is here and we have the building just here, and of course this is a right angle, and this is OP's eye, and of course we're told that that is 1.7 above the ground, and so he's looking up to the top of the building. He's standing 50 meters away from the building, and this angle here is 75 degrees. So let's call the height here h, and compared to this angle, this one is the opposite and this is the adjacent. So if we think so, car, toa, opposite and adjacent means we're going to use the tangent. So we can say that the tangent of 75 degrees would be equal to the opposite divided by the adjacent, and so h is going to be 50 times tan 75 degrees. So we can calculate that, and we've got 50 multiplied by tan 75, and that gives me 186.602 and so on. So 186.602 and so on. Now the actual height of the building, for that we need to add on OP's eye level. So that will be the 186.602 and so on. We need to add that to the 1.7. So that's what we're going to do. We'll just add to 1.7 here. And we want the answer to one decimal place, so I'm going to say 188.3. So that's 188.3 meters, correct to the one decimal place required. Jasper drives a taxi cab in Grid City. Each block is 100 meters long, and for that we need to include either half the road or just ignore the width of the roads. He drives from A to B along the roads. Obviously he can't go through the buildings. How far does he drive? Well, that's 100, 200, 300, 400, 500, and any route you take would be the same as that. So 500 meters. What is the distance from A to B as the crow flies? So the crow obviously can fly above the buildings, it doesn't need to go through them at all. So this is a right angled triangle, this is 300, and this is 200, and this we'll say is D. So D squared is going to be 300 squared add 200 squared. So D squared is going to be 300 squared add 200 squared. So that's 130,000. And let's see what D is. We need the square root of that. So square root of the last answer, 360. Let's give it to the nearest meter. 361 meters, and that's to the nearest meter. Josie is at the top of a cliff 50 meters high. Looking directly out to sea, she can see a swimmer at an angle of depression of 75 degrees and a shark on an angle of depression of 15 degrees. What's the distance between the swimmer and the shark to the nearest centimetre? So if we say this is the cliff, and we'll have the sea along here, then Josie looks out in this sort of direction to see the shark, and in this sort of direction to see the swimmer. So we're not told how tall she is, so we're just going to assume she's looking from 50 meters above. And we know that this angle here is 15 degrees. That's the angle of depression to see the shark. And then this is 75 degrees, this angle here, that's the angle of depression to see the swimmer. And of course, this is a right angle here. So, if we think about this triangle, this angle here is 15 degrees. And we could mark this angle, but let's use what we know about parallel lines and say the angle here is 15 degrees, and of course that means that this one here is 75 degrees, and this is Josie up here. Let's call this point X or something. Now what we're trying to find overall here is this distance here between the shark and the swimmer. But we can work out this distance here, and we can work out this distance here. So let's call this one Y and this one Z. So working in this small triangle here, we could say that the tangent of 15 degrees, it's this angle here, is the opposite divided by the adjacent. So y is going to be 50 multiplied by tan 15 degrees. There's no need to actually work that out at this stage. If we do the same thing in the big triangle all the way round, rather than using this 15 degrees, if that's 15 degrees there, this angle at the top here must be 75 degrees. So tan 75 degrees would be equal to Z, which is the opposite, over 50. So Z is going to be 50 multiplied by tan 75 degrees. Again, no need to work that out here. The distance that we want is going to be Z take away Y, and we can calculate that. So we're going to do 50 multiplied by tan 75, and we're going to take away 50 multiplied by tan 15, and that's, now we want this to the nearest centimetre. This is in metres, so we want 2 decimal places, so that's going to be 0.21. So that's 173.21 metres.